Okay, hello everyone. My name is Jorge Casas. I'm based in Colombia and I'm working at the International Center for Tropical Agriculture. This center is part of CGIAR, which is a big consortium that includes a lot of plant research institutions. And the idea here is, I have been working with ground penetrating radars and this kind of radar data for around 5 years now. But this is, I don't know if you have seen it, but this is a technology that has been used for different uses, especially on construction or like to find ancient things like tunnels and infrastructure and everything. This is also commonly used for mining, but now we are switching the focus for agriculture. So that's why this is a challenge right now. So yeah, I think basically that's it for now. I'm a mechatronics engineer, just like as a background, and also I have a product design master's. But yeah, thank you all for being here, and hopefully I can answer all your questions. You're muted, Amy.
Maybe before we start asking questions, I'm going to break the ice by letting everyone know how confused I was when I first started this project with Jorge, and that the final way it clicked in my mind is that you've got these rows of cassava plants, and then they've got this machine that almost it's on wheels, and they wheel it up the side of one cassava. They then start at the top, and then they walk it down the next. And they take pictures of the ground at different levels. So if you think of a chocolate cake with lots of different levels, so those are the levels that you see the cassava root at. You've also got the left and the right-hand side, and sometimes it's easier to see a cassava root on the left, and sometimes it's easier to see it on the right, especially if the cassava root's at an angle like this. So you'll be seeing a lot of it on the right over here, but not a lot on the, and if you looked at it from the left, you wouldn't see anything. Left, you would see something, right, you wouldn't see. So that's just my interpretation when I was looking at the data. But does anyone want to raise their hand and ask their first question? Ami, Aim, you said you're here to win it, which means that you've got some questions. There we go. Aim, over to you.
So I have a question actually. So the first question was on the data in general. When you start processing the data, you find, for example, there is some folders. If you go, okay, the IDs are unique, but if you go to the folders, there's some folders which appears, let me see, 10 times, and the folder and every time the folder appears, it has a different number of plant numbers and also have some have different, let me say, layers. I'm wondering, for example, what's the relationship between the plant inside the, okay, I want to know what's information about the folders actually, because if the same folder appears 3 times and 4 times, is it supposed to be the same picture of the same plant? I want to know the relationship between the folder and the event taken when they are correcting the image, and also the number of plants, something like that. I'm not sure if I asked very well, but something like that.
Jorge, you want to answer or clarify?
Yeah, I think I got it correctly. So I will start sharing my screen now so I can show you like what's the idea of the organization of the data. Let me know if you're able to see my screen.
Yes, we can share see your screen.
Yes, you can see your screen.
Okay, so basically the idea of this, let me start from the second slide. When we have these this radar data, the idea is we have some experimental plots, and the idea of a plot is to have multiple plants, right? So the distance between plant to plant is around 1 meter. That's a conventional distance that we use in the cassava case. And the idea is if you have a, sorry, can you see my mouse?
Yes,
Yes.
yes, yes. I see
Okay,
it here.
so the idea is you see these arrows here, the equipment will go collecting data this way, and then at the end of the row, which the row should have normally 7 plants, then we turn here and we come back. So basically the left and the right scans correspond to each of the sides, and that's why, like, if you see, for example, in the CSV data that you see like one plant that has the number one, but the same in the same folder, the for the right side you will find that the plant has the number 7. That's why. So the original files that you should have received is if this is the left side of one row, then this is the information you are seeing. So plant number 1, number 2, and all of the plants. And then for the right side, you will find the same numbers, let's say. But the important thing is that when you when you are working on this data, you have to do this to get to the final volume or to the final segmentation results. So this image should be flipped like this. Sorry. And then this image should be aligned with the left one. So basically, if you see here, now we have the plant number 1, the left side, and then the right side. What is considered left and right in the data. So you see the plant number 1 should have this part and this part. Then the plant number 2 is this and this, and so on. So I'm not attaching here like together because as you see here, the cassava plants have the stem and we are not capturing data, like we cannot physically capture data over the stem. So that's why I'm leaving here a gap. But if you want to put it together, that's fine. And finally, you will see here that the plants are aligned. Even one of the questions that were asked in the forums was why this is not the same size, because it is a manual data collection. We are trying to have the same size, but sometimes it is not possible. Even you see here, this is the same row that we collected, and you see a small gap between the left and right. So I don't know if that's clear and if that answers your question, or if you want to elaborate more, then I'm happy to answer.
Yeah, thank you very much. Actually, that one was very also a little bit confusing for me. So the other thing I wanted to ask was actually about the CSV file. So I also even someone actually raised the same question recently on the chat. It was about how data was recorded in terms of on the CSV file on the of the metadata, where we have, for example, that for some we have one folder, and they say, for example, that folder contain let me see, left image, and also another folder contain right image. And then for that folder, they also suggest the good range for layers and everything, also other metadata, corresponding metadatas. But the problem I had for me was actually I can actually see the same folder appearing multiple times, the 2 or 3, 4 times, but also, and the same folder has different number of plants, and also and everything else is the same except the number of plants. And I was wondering, for example, do you have a different plant in every folder, or some folder can have one plant, one like one plant, or no, one folder containing no one plant. I don't know. So I want to know the relationship between folders and images contained inside.
Yeah, every folder has a set of scans,
Okay.
but one scan can contain up to 7 plants, as you see here. Like, let me
Yes.
get these numbers down here.
Mhm.
So this is plant number one. It is not really visible, but it's there. Plant number two, which is more visible. Plant number three, which is very small. Plant number four, which is this long root, and then this small space here. Plant number five, six, and seven.
Mhm.
So for some of the cases, we have some data for different plants across the same scan. So basically, you can use the same scans for the 2 or 3 plants that have volume data. And
Mhm.
also remember that the plant number is always associated with the left side. So the left side will be the reference for plant number 1 or 2 or 3. So that way you can correlate the pixel count or the segmentation, or I don't know, like every strategy you can have to get this size, this root size, to compare that with the volume data that is on the CSV file. Let me know if that clears
So
your question.
I'm trying to get the conversation. Probably other people can ask questions, and yeah, I'll be trying to get the link.
Great. Thank you for those questions, Aim, and thank you for those answers. Stephen Murphy has added some information in the text that I'm just going to read out for the recording. If the images are different sizes, would it make sense to align the end? So increase or decrease large in the size of the image, or to both scale them down? Is that an option, Jorge? Would you left align, right align, scale the images, find the midpoint?
I wouldn't recommend to merge using the endpoint. Anyway, like as you see on the on what I was sharing, that I will share again, the difference is not too big. So basically, if you are like merging the images this way, you can do like a big bots if you want to merge all the data. And then like if it is misaligned from one side to the other, for example, if we do the test here, the difference is not as big as you can expect. So if we align on the right side, it is not the difference is not as big. Sometimes the plant can be misaligned, like in this case for the plant number one, but most of the cases you will see something like this, where the roots will be, let's say, overlapping with the roots from the other picture. So every strategy, like if you align from the left side or to the end side, it's would be fine, I think.
Correct.
But I mean, it is very likely that you won't find like 2 scans having the same dimensions because the data is collected manually.
Thanks, Jorge. I've got a question from Rajesh. Are the provided train labels for all the train plant folders, or just a few of the plants in the folders? If, as Jorge mentioned, we expect to see 7 plants in an image, but sometimes there aren't 7 plants. So this would be the discrepancy. The maximum number of plants you would see in an image is 7, but you could see a range from 1 to 7. Is that correct, Jorge?
Yeah, you will see maximum 7 plants. Sometimes you won't see any plants, like in case of plant number 3 here. Also, you have to take into account that for the case of the volume data on the CSV, uh, sometimes you won't have like the entire row with So you're clarifying here that the provided segmentation labels, all the roots that were found on the images were labeled, so all should be there in the folder.
I hope that helps, Rajesh. Next, we have a question from Efezino. So even when the data says the plant number is number 3 and the plant side is right, do we still then rotate the right image and align to the left image before counting? Or do we reverse rotate the left image and align to the right before counting? Could you please explain the rotating and the numbers again, Jorge?
The rotation process is something that I'm doing just like to clarify to you how this was meant to be. But if you see the relationship between the numbers on left and right side for the folders that have both sides, it is just like 7 minus the number on the left plant plus 1. So if it is for example here, let's go back on this picture. If I return this to the normal or to how the data is delivered to you, if you see it here, like plant number 3 on the left side means and if I have the formula that I just mentioned to you, this means 7 minus left plant plus 1. Then if you see this and if you replace the numbers, you will find that the plant number 3 on the left side will be the plant number 4 on the right side. I think I'm right. Sorry. So basically that's like how the relationship between the data is. If you want, you can just forget, like for the folders that have both sides and you want to do the alignment process that I just did, you can forget about the right side number because the left side is, let's say, more accurate. But I think I remember there are some folders that doesn't have the left side, and that's why we are providing also the right side number.
Thank you for that. Abdul, I see your message. So if he understands correctly, first we must flip the image of the right root before combining the image. Is that correct?
Sorry, can you repeat?
Sure. The first step is to flip the right scan and then combine.
That can be one of the approach if you
Okay.
don't want to use the right side orientation numbers. But remember that the volume data that is provided is for the entire root cluster. So all the volume data that is on the CSV file is merging the data from both sides. That's why I am recommending to use this flipping strategy.
Great. Kalubi, do we need to merge the images? It is one of the steps to solving the root volume. I wonder if there is a way to do it individually and then sum it at the end. So that could be a path you take. Okay, we have a question from Kinga. If we have a box detected for a plant, should we leave a box with a probability, or should we remove the unnecessary data, the probability in this case, and fill it with some color as the box? Or is it necessary to apply a mask in the place of the box detected root so the accuracy is not lost by simply covering everything with a square? Jorge, this one's for you. I think it's about the segmentation model.
Yeah, the idea would be to use the segmentation part because when you use the bonding boxes, you simply have a box, but it is not like if you have a long root, like in this case, you will have a big box, but then it is not showing you how big really is the root. So if you're basic basing your like I don't know a new model that is uh, working with the boxes and the volume data, then from my perspective, that model won't be as accurate as if you're using the segmentation part. Because the segmentation, for example, like one of the basic approaches that I think would work is if you segment the roots, then you count the pixels that are inside the segmentation, and then you can have like a basic linear regression if you want to see it that way, uh, like correlating the amount of pixels from both left and right side, correlating that with the volume data, and then that way you can have an estimation of the volume for the testing, basically.
Great. Thank you, Jorge. Rodney, let's get down to some units of measurements. What are the units? What units are the values in the start and end columns in the data set, Jorge?
I think this is related to the layers. What is happening here is sometimes the signal of the radar equipment at the beginning, it is basically a lot of noise. And our estimation is that the first 10 layers is just noise. That's why all of the recommended like start and end columns are like from layer number 10 up to, I don't know, in some cases, I think it is like 30 and 40. But it is not a like unit, a defined unit. Some of the estimations that we have done is that the distance between all the layers, because remember that those layers are like a top view of the plants. The depth between layers would be around 3 millimeters, but this is just an estimation that we did.
And then the second question from Rodney. Some of the root volumes are 0. Are these actual measurements or are these errors? This is Rodney, I'm assuming, in the train set.
Yeah, I think some of the like these questions can go both ways because in some cases you can see some roots with the radar, but then this root is rotten. So it is the volume data is not taken because the conditions are different, and that's why it is 0 on the CSV file. And sometimes you can have some volume data, but if the root orientation is like close to the stem, like for example in this case, if you take a scan of this, you won't see this root because this root is aligned and in the same direction of the stem. So this root won't be captured from the radar. And if most of the roots are on this orientation, then you won't be able to see any radar data or any pictures from the roots, even if you have some volume data. So if you have that case, then you have to ignore that data point.
Great, that's something I didn't even know. Thank you, Jorge. I'm just going to repeat the question and answer to Kolibali. As Jorge aligned the image on the screen, is this the main task for us to do with each folder? Yes and no. Yes, because Jorge has shown how nicely it is to do here, but if you can find a different way to look at these individually, then that is also an option. So our end goal is root volume. The way you get there, either through merging the files, flipping and merging, or looking at them individually will work. I hope that helps.
Yeah, as long as you're keeping in mind that the volume data, the volume data from the CSV file is from the combination of of both pictures, left and right. So like just like the flipping idea was just to show you that the plant number 2 from left side is the same as plant number 6 from right side. So you have to merge the I don't know, the pixel count or the segmentation part that you will get from this and from this, and that way you will know that uh, that's what you can correlate directly with the volume data from the CSV file. You can work it independently, as Amy said, or you have to flip it and merge it so it is more visually clearer.
Great, thank you, Jorge. Question from Julio. Can we assume that the different plants in each scan have the same genotype?
Yeah, every scan should be from a same genotype. I'm not sure if the genotype information was shared with you,
No,
but
not share genotype information because it was the same genotype.
yeah, like all the 7 plants that you're seeing here are from the same genotype.
Michael, you have a question. Do you want to unmute yourself?
Yes, please. I have 4 questions actually. Thanks a lot for the great explanations. Just just a few questions about the CSV. For example, if only the right side measurements are specified in the training set, then actually according to what you said, the left side symmetrical 8 minus the count numbers should also be part of this training set actually, right? Like if for example I see a plant that has only 3 the same folder name, but it has only 3 right and it has a volume, and 1 right and it has a volume, like 2 plants from the same folder. But actually, it's the same as 7 left and what did I say? 7 left and 5 left, right? These lines are not mentioned in the CSV, but actually they could be. They should. It's the same thing. It's the same plant actually, right? Like 1 right and 7 left, which is not mentioned in the training set.
Yeah,
Actually,
you're right, but actually, like from my point of view, if the left side is not mentioned on
yeah.
the CSV file, that was because there was no clearer information on the left side of the scans.
It wasn't visible.
It was not visible to me. I mean, like if you are able to get some information from there, that will be good. But
Yeah.
this information is just the suggested layers, and we don't like there is no left side information because I couldn't find any suggested layers for the left side of that specific scan. And that's why it is not present on the CSV. But your reasoning is okay. And if you want to get or if you want to try to get some information from the left side of that specific folder, you can try.
Yeah, so it's related to the start and end layers. That's what you saw manually, right? This is
Yeah,
the best layers that you saw. Because actually, when I look at some of these layers that are recommended, I don't see anything. So uh, you say that these are the layers that you see something. if you look an expert view looking at this data, they see something in these layers that are mentioned, the start and end layers.
Yeah.
Yes? Okay, just another quick question. Thanks a lot. Another quick question regarding the example you gave here, the 7 plants. They're not equally spaced, for example, in this example. And in some of the on the scan, when I looked at some of the folders, sometimes you don't see all the 7 plants. That's a known problem for all of the people. So some of the suggestions are to assume an even or a uniform division between the 7 parts. But and actually, if you look at the distribution of the segmentation labels, they're more or less distributed evenly, but they're not always. Even in the example you give here, it's not the whole segment is not evenly divided to 7 parts where the plants are. So my question is actually, you explained the technical process that you did, that you scanned the whole row with a GPR, and then you turn around and scan it from the other side. Should we assume that the volume more or less is the plants are distributed evenly in the scans that were given? Or you think we should we should not count on this assumption? Like an approach could be like to divide the whole thing to 7 parts and then analyze each of the subsegments individually. Or you say I can't depend on this and I have to work on some kind of segmentation on the whole to actually look for the parts and not assume that they exist in the seventh parts of the whole segment. Do you understand my question? Can I depend on it or not? That it's in the seventh division of each scan, the relative position.
You can assume that the plants are evenly distributed. Sometimes you won't see it here because some of the roots will try to go even to some direction and to other direction. So basically, like I can do this, move this a bit here, and then I can move this again. So basically, what we are seeing here is, and I'm just going ahead and answering another question that is in the chat. I'm doing this kind of flipping because if you see here, I will zoom in a bit. The root clusters are starting from this side. So basically, I'm just flipping this way because it is like easier to me to see the same as I'm seeing here. Like this kind of picture would be how the data is collected. And then if you see here, I'm giving this gap. So basically here on where the mouse is should be where the stem is, and that's why I'm flipping this way. And going back to your question, yeah, you can assume that the plants are evenly distributed. Even like now it is more clearer. Maybe this number should be more closer to this side. And then I think that's solved. But yeah, ideally all the plants are planted at the same distance.
Yeah, but also the edges. You see the edges on the right side, on the right side of 7. There's a large interval on the right side. I mean,
Eh,
so
yeah, so sometimes it can be longer here, and it is eventually longer at the end. But we are always trying to measure from here to here between 50 centimeters to 1 meter, and from plant to plant, it is like in actual measurements, it is between 80 centimeters to 1 meter. That's like the conventional dimensions or the distance between plants for cassava case.
And in the beginning, it's 50 centimeters, you said, before one?
Some of the scans should be 50 centimeters and some of them should be 1 meter. I don't have like clear which one are 50 and which one are 1 meter because we were testing different protocols, but I know that should be the approximate distance from the beginning. And after the last plant, we are always leaving a space so all the data is captured. So we cannot start at like where the first plant is because then we are missing some information, and then we cannot end where the last plant is because we can also miss some information that can be on this side.
Right. Just one last question. The processing that was done to the signal here, the radar signal. I saw that the GPR is supposed to have hyperbolas. I think that's what it's called, right, or something like that.
Yeah.
So some processing was done here to maybe minimize this or to emphasize the value the root themselves, right, or something. Can you maybe specify, maybe not now, maybe or maybe you can. Is it supposed to have the hype these shapes, or some analysis was done to emphasize the roots in this analysis? Or can you just say what kind of processing is done to the images?
There is some data transformation procedure. So let me draw his. So ideally, the radar data should be something like this, as you're mentioning. So there are some hyperbolas, but these hyperbolas are coming from every channel. So for the specific case of the antenna that we used to collect this data, we had 14 different antennas, and then as we know, like the distance between the antennas, that's why we can generate like a composite
14 is
image.
14 is actually the y-axis, right?
Yeah, that's what I was going to. So that's why you will see 14 pixels
Yeah.
of height here, and it is because every pixel is from every of the antennas, and then like if you see, then we can have like a set of hyperbolas that is going like assume that I'm going out of the screen, and then like the 3D reconstruction of this set of antennas or B scans will lead us to this kind of pictures. So that's why we are getting the top view and not a side view, because ideally the hyperbola's vision would be a side view of what you are capturing.
Yeah, by the 14 antennas are side to side actually.
Yeah, they are one next to the other.
One up to the other. When you go forward down the road, they're actually on the cross side, on the going to from side to side.
Yeah,
Okay, thanks a lot.
you're welcome. So yeah, I think there are a lot of more questions on the chat.
Oh, Jorge, let me read them out so that just
Okay.
in the recording we've got them. How is the root volume calculated during data gathering?
We have a big bucket, and we know like we are submerging the roots, and then we are measuring like how many centimeters the bucket level is going up, and we have a relationship between like those centimeters and how much liters are actually displacing, and that's the measurement, and that's why the final uh, measurement is given in liters.
Great, so it's water displacement.
Yeah.
Zainab has asked, are we supposed to drop folders containing missing values? My recommendation there is if it works for you, do it. Otherwise, see if there's another way. Jorge, is there anything else that you'd like to add there?
No, no, I think that's fine.
Great. What do the labels on these segments or bounding boxes represent? For example, plant root identification ID numbers plant 1, plant 2. Does plant 1, plant 2 mean root or not root?
No, it is just a root class. That's it.
Great. I hope that answered your question, Naya. Abdu, have the scan images already been augmented? Abdu, I'm assuming this is in relation to your question that you asked earlier. Oh, no, it's not. Abdu, do you mind unmuting yourself and asking the question?
Yeah, sure. So my question is, have the scan images already been augmented, or we can do it without introducing a lot of noise? Because if the images have already been augmented by applying another set of augmentation, we're just going to introduce a lot of noise in the data, and it's going to impact the way our model will perform.
The images have not been augmented, but my recommendation would be to be careful with that because sometimes you can find a lot of noise and like if you want to augment the images, then you should be very careful on what strategy and which part of the images you want to augment because like from my perspective, the best way to do that would be to merge the pictures like this. I hope you're seeing my screen, and
Yeah.
then to augment only the ones that have a big space overlapping between the roots, like this one or this one or this one, but not to augment this kind of pictures or this kind of plants, because then that can generate a lot of noise and like we understand why this is next to this, but then like in the augmentation process, there can be some noise that can affect like the real structure of the roots, and then it can affect finally the performance of the model.
Okay, thank you very much.
Our next question is from Kinga. What's the difference between layers in centimeters?
It is an approximate of 3 millimeters, but that's calculated based, sometimes it can be more or less, depending on also on the soil properties. So this is not something to rely on because the data that is on the challenge is from different locations and different soil types. So just to be careful on that.
Great, thank you. Question from Olayinka. The explanation for measuring root volume suggests that the root was extracted from the ground to do water displacement, but the challenge page says it's non-invasive. So how does that work?
Yeah, basically we just extracted the data needed to create the model, and the idea is in the future when we can assure that this technology is working for agriculture, then we don't have to harvest that. So we can just use the GPR over the roots and then we can calculate the volume. But at this point, as we don't have like a real formula for volume and or weight extraction, because that's also one of the traits or characteristics that we would like to measure using GPR. As we don't have a model or a strategy for that, that's why we are still harvesting. But in the future, the idea is to be non-invasive, as it is mentioned on the challenge.
Great, thank you. From Mohammed. In the data, some folders only have plant number, for example, only plant number 2, meaning that the other plants were not visible. What's your recommendation for these cases on the test data?
Uh, I think that that's a wrong approximation because if we have only one plant number, it means that the volume data was only collected for one plant. But remember that the scans will always have the 7 plants. Even in some cases, you can have, as I previously mentioned, you can have the plant volume data, but you won't see that specific plant in the scan.
Thank you. Naya's got another long question. Does the pixel area of a plant's polygon directly indicate its real-world size within the image? For example, does a larger polygon mean a larger plant? Can we compare polygon areas across different folders? If plant 1 in folder X has a larger polygon than plant 1 in folder Y, does this mean the plant in folder X is larger than the plant in folder Y?
Yeah, that can be a great assumption. I don't have numbers exactly to provide to you, but if